Okay, well, here is my extra credit for my midterm 2. Here is the solutions for our midterm 1, question 3A and 3B. So here is our question 3. Above is a motor operating in steady state being driven by a constant voltage source, Vs equals 5 volts, and a PNP transistor controlled by an Arduino microcontroller. The microcontroller is represented by VA. The motor is represented by Rm equaling 1 ohm. The PNP transistor has a beta equaling 150 and an Ra equaling 500 ohms. So for question 3a, it states label E, B, C, VBE, VBC, VCE, IB, IC, IE on the PNP transistor below with the correct PNP convention for polarities and current directions. So right off the bat, I'm going to say if you're not sure what a BJT is, a transistor, PNP, or NPN, I suggest you go ahead and check out my previous video, which I go over and let you know about all these items that we're about to go over right now. So let's go ahead and start labeling. So we're going to go ahead and label our E, which is our emitter. We're going to label that down at the bottom. And then our collector at the top here, and our base over here on the right. We're going to go ahead our voltage between our base and our emitter, base and collector, and collector and emitter. And then our polarities, negative, positive, negative, positive, and positive, negative. Oops, fix that. Okay, now that we have our polarities and our voltages labeled, we can go ahead and label our currents. IC, IB, and IE. And there you have a PNP transistor. So there you go. There's our answer for 3A. So let's go on to 3B now. Oops. Okay. So here I just went ahead and took a picture, or not took a picture, drew the diagram for us of the previous question. We have our, well, let's go ahead and read the question. Using the large signal DC method, determine which region the PNP transistor behaves in when the microcontroller is outputting VA equals 5 volts. Excuse me. Do not use the NPN method and be careful of labeling E, B, and C. Sorry again. State all laws/equations used. Okay. So here's the drawing I did. I relabeled everything. I labeled our emitter, labeled the collector, and labeled the base for our PNP transistor right here. I labeled our 500 ohm resistor, our 1 ohm resistor, and our Vs equaling 5 volts. So if we go over here and look at our regions graph that we were given in class by our great professor, Mr. Chang-siu, we look over here and we need to assume one of these regions before we start working on this problem right here. So we're going to go ahead and assume cutoff, which means that there's no current. So I did some research in our Hambly book, and I found that in page 622, for a PNP to be in cutoff, it needs to meet some kind of requirements. These two requirements right here, that our voltage between our base and our emitter is greater than negative 0.5, and the voltage between the base and the collector is greater than negative 0.5. So we're going to go ahead and check those out right now. So for our VBE, we can go ahead and see that our 5 volts is coming in from Vs right here. So we have 5 volts being received to VBE. And then for our VBC, we're going to go ahead and do handy dandy Ohm's law, where our current there is equal to 0. So therefore our voltage would be 0. Therefore, we'd have no current because we assumed it in cutoff, and now our state is in cutoff.